Hello, everyone. My name is Roman Boyko. I'm a specialist solution architect for serverless here at AWS. And today I'm going to talk a little bit about how you can simplify running your code and how you can deliver new applications and new functionality with less effort. So let's get started. And today I'm going to talk about our serverless portfolio and serverless services and what it means to you. First of all, if we start thinking about serverless, what it brings to you as a developer. First of all, it makes you think less about infrastructure. So you don't need to focus on servers, on managing, patching your infrastructure. And you can focus more on delivering business logic and business functionality to your customers. And of course, serverless solutions can be more cost effective because you only pay for value and for the amount of resources you consume. And as with serverless, AWS takes a lot of efforts to secure the underlying infrastructure. That means that you, again, can focus more on high-level constructs and don't think about low-level security. And usually, if we think, what can we build with a serverless approach and serverless technologies? Really, you can build a lot of things, and really you can build almost all types of applications you can do without serverless. But the main focus probably will be around web applications, some processing of data, maybe doing some IT automation, because again, talking about serverless, you can easily integrate, for example, Lambda functions with different actions and different events coming from other AWS services. And of course, you can automate different machine learning things and do, for example, inference with Lambda functions. But if we are talking about serverless, there are plenty of different services on AWS. And serverless is not limited with Lambda functions and AWS Lambda. Probably if you start thinking and start working with serverless, this is the first service you will heard. But we have many others. For example, on the compute side, there are some workloads which are not well suited and fit well into Lambda runtime, but they can benefit from running in containers. And we have AWS Fargate for that. For example, if talking about data stores, we have a lot of options, but probably the most widely used ones, if we're talking about serverless approach, are DynamoDB, Aurora Serverless, or S3. And of course, if we are building some kind of microservice-oriented application and building some complex logic, probably you will have a lot of different parts in your application which need to talk to each other, and you need some kind of integration patterns and integration technologies to bind them all together. And yeah, we have a lot of different integration options, starting with API gateway if you want to build RESTful APIs, or AppSync if you are more into GraphQL style of APIs. And we have a number of services which will allow you to build event-driven architectures like Event Bridge, SQS, SNS, and step functions. But today, we'll be focusing more on AWS Lambda as the main service for the developers and which allows you to run your code. On a high level, what Lambda does, you can register the Lambda service to get events from different sources. It might be events coming from API gateway, from HTTP requests. It might be events coming from asynchronous communication like queues in SQS, or rules in event breach. And then you implement some business logic. And your business logic is implemented with different programming languages. And the good thing with Lambda is that you can utilize a lot of different options here. We have so-called provided and managed runtimes, which are managed and created by AWS. And we have plenty of options here like Python, JavaScript, Java, C#, and Go. But you're not limited with only these provided runtimes. If you need, you can create your own and bring your own runtimes. For example, if you're using PHP or Rust or any other language, you can create your own runtime and use that runtime in Lambda to build your functionality. And of course, you will integrate your functions with different other AWS services, maybe some external databases and external APIs. Looking closely into a Lambda function, how you can start and how you build your functions and your code. First of all, you should provide a so-called handler function. This function is an entry point into your code, and it will be executed by a Lambda runtime when the event comes. And the Lambda runtime will pass to that function two parameters, the event and the context. And the event parameter will have all the information about the event itself, about the data which was sent by the external system to the function. For example, if it's an API gateway call, it will have some information about HTTP headers. If it's a POST request, it may contain information about body of that request and any additional information. And another parameter is a context. This is a parameter which have some additional information about Lambda runtime itself. For example, request ID, time remaining until the end of the function, and some other useful information which might be useful sometimes to refer in your Lambda functions. And in addition to the business logic and to the code you put into the Lambda runtime, you need to provide a number of configuration options, and there are plenty, and they all well documented. But talking about the most important ones, first of all, you need to provide a number of memory allocated to the function. And essentially, this is the only hardware configuration you need to set up for your Lambda function configuration. But depending on the amount of memory you set, Lambda runtime will allocate proportionally the number of CPU power. So the more memory you give to your function, the more CPU power it will get, up to 6 virtual CPUs for 10 gigs of RAM. And tuning these parameters sometimes may bring additional value in terms of performance and cost. And today, during our demo, I will showcase you how to find the best configuration in terms of performance and cost. And of course, in terms of security, you will need to provide additional information about what resources are available to your function. For example, you can create an IAM role saying that this function can access a particular DynamoDB table or S3 bucket. And also you can tell that this function may be only executed by an API gateway or an API call or some other AWS service. And another things you can configure is timeout. And by default, the timeout will be set to 3 seconds, but you can extend it up to 15 minutes. And this is the maximum, the time your Lambda function may run. Also, you can, depending on the event source, your function may be run synchronously or asynchronously. And sometimes if you need your function to access additional resources within your VPC, you can attach it to a particular VPC and then configure this VPC connection. And then you will need to provide some security groups, group rules, just to restrict and provide the necessary access. And the last important thing I wanted to mention in terms of configuration for your Lambda functions is the architecture options. And there are 2 CPU architectures supported by Lambda runtime. The first is x86, traditional Intel and AMD processors. And quite recently, we announced ARM64 architecture support, and it is powered by our Graviton 2 process. A few words about Graviton 2 process and why you should care about them. First of all, this is an ARM architecture process, but the design and production of this process is done by AWS. And at first, we announced them to run on EC2 instances and then expand the support into additional services. And right now, if you want to try and utilize ARM architecture, you can use Lambda as the easiest way of doing that. And especially if you're using runtimes and languages like Node.js with JavaScript and TypeScript, Python, Java, it is a matter of switching the type of architecture. And you can test the same code and the same logic both on x86 and ARM architectures. And we support a number of different runtimes, and you can use those runtimes to run on ARM architecture. In terms of workloads, what workloads can you run? Basically, almost all workloads can be used on ARM architecture, except maybe if you have specific libraries which were compiled specifically for Intel or AMD process for x86 architecture, then probably it will require extra time to recompile those libraries into ARM architecture and to test everything. But again, if you're using interpreted languages like JavaScript with Node or Python, then it is quite easy switch, and you can test both architectures and see what architecture plays better for your use case. And the good news here is that usually what we observe from our customers is that Graviton and ARM architecture performs a little bit better. And also it will cost you less. So I highly encourage you to test and to compare all the options and try to build and run your functions with ARM and Graviton process. But let's look how you can do that. And for that, let's create a function. I go to a Lambda function console, click on Create button. provide some name, demo function, for example. And for this function, I will be using Python runtime. And for the architecture, I will now use x86, which is more common still for many architectures. And if you go to the console, you see that you can edit the code in the Lambda console itself. And that, for example, if you create a new function within the console, there will be a small hello world application. But let's change this code into something more complicated, because in the next demo, I want to show you how you can change and find the best performant configuration for your Lambda function. So again, this is quite simple code. It just seeks for prime numbers in a loop, quite big loop. So it will take quite amount of time and CPU power. And then it produces a result in forms of what architecture was used, how long it took to find all the numbers, and how much numbers were found during this run. So I need to deploy this new code. And also, I need to change a couple of configuration parameters. So I will go into configuration tab and see that there are a lot of things you can change and configure for your function. But right now, I just want to change the memory and the timeout of the function. Because I want to assign slightly more CPU power, and I assume that this function may run for longer than 3 seconds. I change these parameters, click on Save. And now I want to test my function and go to the Test tab. Here you can define what type of event and what information in that event will be sent to your function. But right now I don't depend on the event because I don't process anything. So I will send just default one and see my function has run, and it was running for 24 seconds and found 78 something thousand prime numbers. Let's try this same function, but with ARM architecture. So it is easy to do. So if I scroll down in the function configuration and look at architecture, another great thing here is that you can click on Info tab for any parameters and get some pop-up window with information and useful links to the documentation to get more information. And now let's change the configuration to ARM, and that's it. Actually, with this small change, I changed the type of processor. Imagine if you're using any other kind of architecture, how long it will take to provision a new virtual machine or to create a new container. With Lambda, you just switch one option, and now your function will use ARM architecture. Let's test it. And go to test and again run the test. And we see that now, our function run on ARM architecture, and it run 17 seconds, which is better result. And it has found the exact same number of prime numbers. And here comes the question, how I can compare to architectures, to styles, and how I can find the best configuration in terms of performance and cost for my Lambda function. If we look at pricing configuration and for what you pay here, you see that there are two main dimensions for the pricing in a Lambda function. The first is number of requests. So the more requests you send, the more you will pay. And the second dimension is duration. And duration is measured in gigabytes per second. That means that the more memory you give and the longer your function running, the more you will pay. But here comes another interesting thing is that, for example, if you take the same function and this function will run for 100 milliseconds with 2 gigabytes of RAM, this is the same, you will pay the same value if this function will run for 200 milliseconds with 1 gigabyte of RAM. So finding this balance sometimes is challenging. And another thing you should remember is that the more memory you give, the more CPU power you will get. So sometimes giving more memory will give your function more CPU power, and it will mean that your function will run faster. And to find the best option here, you can use open source tool, which is called Lambda Power Tuning. And it essentially allow you to run the same function with different memory configurations and find the best configuration in terms of price and performance. Let's look how you can do that. Okay, I will be using the same function. And first of all, I need to install this power tuning thing. The easiest way to do the installation is to use this serverless application repository. If you open it and search for Lambda Power Tuning, you will find this application called AWS Lambda Power Tuning. In case your search doesn't show this result, make sure that you click this option, Show Apps with Custom IAM Roles. And after that, you may click on this application. You will get the description and the number of parameters. But for the sake of this demo, I will keep all the information as it is. There's a GitHub repo associated with this application. And if you go to that repo, you can get information and documentation. And now I click on Deploy. And yeah, my application is deployed, and essentially it has a step function state machine, which will run different configurations for your function and plot a graph with the information. So I need to go to this step functions. And in the state machines, I will see this state machine deployed. If I click on it, I can start execution. And here I need to provide a little bit of information of what function I want to test and some additional parameters in terms of memory configurations I want to test. For example, in this case, I want to test. So in my case, I will test my function with the following configurations, starting with 128 megs and up to 10 gigs. And also you need to provide your function ARN. To find it, I will go back to my Lambda function, and here in the function overview, you can find this function ARN. Just copy it and paste back to Lambda ARN and start execution. So this state machine essentially will run in parallel different configurations of your Lambda function with different memory settings. And once done, you can scroll up and go to this execution output. You will see a link to a dashboard. So let's copy this link and see what we have here. And you see that in this graph, there are two things. First is invocation time, and you see that the more memory it gets, to some extent, the function performs better. And here you can find different characteristics that the best cost is achieved at 1 gig and best time at 6 gigs. But looking at the graph, I would say that it's not worth going beyond 2 gigs for this particular function, because you see that the price will raise, but the performance will reach a plateau. And if you again see at this graph, you can determine that probably the best characteristics and best configuration for this function lays in between 1 gig and 2 gigs of memory. So probably you may run additional tests for those configurations if you need more granularity. But again, it give you good assumption. And we run this for ARM architecture. Let's try and run the same for x86. So we can compare not only memory configurations, but the CPU configurations as well. So I will go back to my step functions. And here I don't need to change anything because I will be running essentially the same function, and I already changed the CPU configuration. And now the same function was run with x86 architecture. And here you can see another plot. And in this plot, you see almost the same graph at first glance. So the optimal configuration lays somewhere in between 1 gig and 2 gigs of memory. But how it compares to ARM. And here we have a good option in this power tuning tooling, which is called compare. And it allows you to compare 2 different options and 2 different graphs. If I click on compare button, I can name this graph, for example, x86, and then I need to copy the link to the previous visualization and call it ARM, for example, and click on compare and see in this graph we have now comparison between x86 and ARM. So you see that invocation time for ARM is better and price is lower. So basically for all the configurations for this particular code, for this particular function, ARM and Graviton performs better and cost you less, which is great. And you can, for example, go and see the comparison for different options. So, for example, if you go and look at, let's say, different configurations, let's look at the most interesting ones. For example, at 1 gig, we will have 28% faster and 41% cheaper function execution for Graviton and ARM processors. So this is pretty good, but again, different code may behave differently, and you need to compare the different scenarios and different cases one by one. But in general, what we observe for many workloads, especially if they're not specifically bound to x86 architecture, you will benefit from using ARM and Graviton process. And this is quite simple functions. What else can you build, and why should you at all care about serverless architecture, and what different patterns can we have, and what different things you can build with Lambda and serverless? Let's look at a high-level view. First of all, yeah, you can build different kinds of API-driven architectures. So if you want to create a REST API or GraphQL API, you can use API gateway with a number of Lambda functions connected, for example, to a DynamoDB table, and you can create such CRUD microservices which will scale fast and be quite available, resilient, and will require less effort in terms of development and in terms of operations. And again, as I mentioned, you can use different styles of APIs, REST, GraphQL, etc. But this synchronous communication is good, but it also has its drawbacks. For example, if you introduce a lot of synchronous communication, you will spend a lot of time waiting for the responses. That's why for certain cases and for scalability thing, you should think and should try to implement different kind of event-driven approaches. And again, here's serverless, Lambda, event bridge, API gateway, and all other AWS services will help you a lot. So you can start implementing event-driven architectures and decouple your microservices and your architectures. And sometimes, yeah, it may require additional effort in terms of designing and architecting all the things. But in the end, you will get more resilient and durable system. And another thing I wanted to mention here is in my first example, I was creating a function directly in AWS console. For small experiments, it is a good practice and it is a good option. So you can just open a console, write some code, immediately execute it, change different parameters, see how your code behaves. It's easy and fast. But if you start building something bigger, if you start building a bigger application, probably you will need to introduce some kind of CI/CD. You will need to create some kind of pipelines, DevOps, etc. And here you will need some tooling to help with. And if you are in the beginning of your serverless journey, I highly recommend you have a look at AWS SAM or Serverless Application Model. This is a framework which helps you a lot with building and creating different serverless applications. And let's see how we can, for example, create a simple CRUD API with the help of SAM and API gateway, DynamoDB, and a couple of Lambda functions. To do that, I will be using SAM, and SAM also have a CLI, which allow you to run different commands in your command line. And for example, if you run SAM init, you will have this visit. You can select different options. For example, in this case, I'm creating a serverless API, and for this case, I'm using Node.js runtime. And again, you have different options here. And I will call this application demo app. And SAM will create a folder structure, and it will create some demo code to start with. Let's look at this code briefly. The main thing here is a template YAML. This YAML file actually describes your whole application. So if you look at this YAML file, you see that there's a header with some metadata, and then there's a resources section, which essentially defines a number of Lambda functions. And here you see that I define all the parameters like the handler, the runtime type, CPU architecture, memory configuration, timeout, and many more. And then I also register that this function will respond to a particular event, get event for REST API. Then I have another function which will respond again to the get method, but to the ID path. And then I will have the third function which will respond to post method and write some data to a DynamoDB table. Let's look briefly in the source code. So you see that I have three functions: get all items, get item by ID, and put item. It's quite simple functions. So I have a handler function defined, and for the get all items, I just reference a DynamoDB table and use AWS SDK just to run a scan command on that table and return all the results to the API call. The second one is get by ID. Here I need to deal with the event. So from the event, I extract the ID from the path parameters. And then I use this ID to make the request to the DynamoDB table and to get the item and return it to the front end, for example. And the last one is put item. Here I am extracting from the event the body sent via HTTP post request, and that body should consist ID and name. Again, here I don't have any particular checks. In reality, maybe you will check that there's a corresponding parameter and it's not it is not empty, but for the sake of the demo, I just extract that data and make a DynamoDB call. And now I want to deploy this application, but as we're talking about different architectures and different CPU style, I want to run my functions as ARM architecture on Graviton processor. But I don't want to change each function and each configuration separately. So imagine here I have only 3 functions, but in other cases I may have like more functions, maybe tens or even thousands of functions. And if I want to change some common parameters for each function, it might become quite a challenge here. So I may use so-called global section, and let me add this global section. And in this global section, I will put some common parameters for all the functions. In my case, I will extract architecture and runtime. So I will manage this centrally for all functions, which probably is a good choice, because usually I will change the runtime for all the functions maybe, and again architecture for all the functions. Let me do that, and then I can delete this information from each correspondent function configuration so that the global one will be applied. Let me save this file, and now let's deploy this application. So I first need to run SAM build. SAM build will, in case with Node.js application, it will just run npm install and package everything as a zip archive to be deployed on a Lambda runtime. And then I can run a SAM deploy. Again, I will have a wizard to configure different parameters like region where I want to deploy. Do you need create IAM roles? And here, as you see, my API is not protected at the moment. So, and SAM is good in detecting that, and it just warns me that if I deploy this application and this API endpoint, it will be available for everyone. Is it okay? So probably for this demo, it's okay. Maybe for the real world scenarios, you will need to introduce some kind of authentication and authorization to protect your API. And after that, essentially, I answered all the questions, and now Sam will spend some time deploying my application. Under the hood, it is using CloudFormation, so it will create a number of CloudFormation resources, like again functions, roles, tables, etc. And in the end, I will get all the information, all the functions deployed. So deployed. If I go to the functions section, for example, and refresh it, you see that now I have 3 functions deployed, and it is Node runtime, and it is registered to respond to some API gateway calls and using ARM architecture. So let's then test this application. I go back to the console. Once my template finished running, it also will output this API endpoint, and I will use this API endpoint to make a couple of requests to make sure that everything is working as expected. So I just expect that URL. And then make calls with curl utility. So first I want to put some data and to store some data. So I will use post method. So I will save item 1, and then I will save item 2, for example. And then I can test that, this data was saved. And if I run a get request, I will get either all data for the root path, or if I went with ID, I will get data for a particular item. So you see that using SAM, you can easily build and deploy different applications, bootstrap your folder structure, get some code samples, and again, choose different architectures easily, change them, test what fits you better. And now let's talk a little bit about best practices. What should you pay attention while creating and building your serverless applications? First of all, you should remember a couple of things about Lambda functions. So first, it is runs on demand. So once you have requests coming in, Lambda will provision the necessary runtimes and scale them up. And if you don't have requests, it will scale them down. Again, you can use different runtimes, so you're not limited with Python or Node, which I was using today. You may use Java, you may use Rust and other things. All the communication is event-driven, so all the all the calls to the Lambda function, they're different events. And all functions, they're stateless, so you can't store state in Lambda runtime itself. If you need to store state, you will need to use some kind of an external storage. And here comes different best practices. First of all, don't do lift and shift. Sometimes I see customers just get their Spring Boot application put into a Lambda function and feel that it's not performing well. It has slow startup times because essentially Lambda doesn't fit this execution pattern. Try to minimize your functions. Use one function per purpose. For example, as in the latest demo, there were 3 functions for each CRUD operation, for getting all items, getting a particular item, and saving the items. And you should try to follow this pattern and keep functions small and delivering one purpose. Again, you may use different runtimes in different configurations. For example, maybe for some runtimes and some configurations, x86 architecture will perform better. Maybe for other ARM will perform better. And again, you can easily switch and test all of them. Some other best practices. Remember that infrastructure is disposable, and you can easily use in some kind of infrastructure as code tooling like SAM, CDK, or other, easily create different types and versions of your infrastructure and test different configurations easily. Try to think asynchronously and apply asynchronous as much as possible, because it will bring you benefits in terms of reliability, scalability, and you will create less coupling between different services. Of course, you should remember about security, and from the ground up, try to apply different and granular IAM roles and permissions. So don't use asterisks in your IAM policies to allow everything, because then you for sure you will forget about it and it will go into production, and then you will have a security exposure. If you're using Python, Java, or TypeScript, I highly encourage looking at these power tools. It greatly simplifies a lot of things around observability, tracing, logging, and metrics. Also, we have a well-architected framework with a serverless lens. So if you're building a serverless application and you want this application to be well architected, I highly encourage looking at this well architected framework specifically for serverless. And the last thing, today I showed you a small CRUD application. We have plenty other samples. For example, we have this different languages sample. We just created the same application in different languages and runtimes, so you can look at the differences, compare them, and choose what fits you best. With that, thank you very much for your time, and now I'm open to questions from you.